A-Level Chemistry Paper 3, 2018. Question number 1. Probably the hardest question on the paper, and it caused a lot of problems. So we've got iodide ions reacting with hydrogen peroxide ions and reacting with H plus ions. The rate equals the rate constant multiplied by the concentration of hydrogen peroxide multiplied by the concentration of iodide ions to the power 2 multiplied by the concentration of H plus to the power 2. So a large excess of H2O and I minus is used so that the rate of reaction is only affected by H plus. How can that be? Well, what actually happens is if you use large excesses of these hydrogen peroxide and iodide ions, then any changes in concentration to these are negligible and so will have no effect on the rate. The easiest way of explaining that would be if, say for example, I poured a cup of salt into the sea, it would have a negligible effect on the concentration of salt in the salt water. That's because the sea is so large. So changing the concentration of these is going to have a negligible effect because you're using a large excess of them. And now I want to measure, it says that you're going to titrate with alkali to determine the concentration of H+. What must be done to the sample before it's titrated? Well, you need to stop it reacting. So you've got to stop it reacting so you can determine the H+ concentration at that point that you've taken the sample. So the best way is to stop the reaction maybe by cooling it or maybe by adding some water to dilute it so that it stops reacting. You get a straight line on this graph. So if you had a curve, you'd take a tangent to the curve and you measure the gradient. We've got a straight line, we haven't got a curve, so the gradient is staying the same throughout, it's remaining constant. Now the gradient is the rate, so the rate is staying constant. So you've got a constant gradient as the H+ changes, and therefore the rate isn't changing. So that means that the order with respect to H+ is 0. Changing the concentration of H+ has no effect on the rate. So the rate equals the rate constant, because if the H+ concentration is having no effect on the rate, and the other chemicals, the hydrogen peroxide and iodide, are in large excess and they're not affecting the rate, then the rate constant equals the rate. Yeah. So the gradient equals the rate constant. So we take the value of y, 0.5, we divide by the value of x, which is 420, and it comes out as 0.0012. What are the units? Well, the moles per decimeter cubed divided by seconds, so that works out as moles per decimeter cubed, mole dm to the -3 divided by s, so that's s to the -1.